All right, guys, so today we are going to be talking about specific special cases when factoring. There's two main cases we're going to look at and kind of how they work. They actually work really nicely, so I think you'll like these. All right, and then this will help you with the Canvas quiz that you'll be doing today as your homework. So it'll be a homework grade and for attendance. So first case that we're going to look at is specifically called the difference of squares. Why it's called a difference of squares is because if you look at this first example, there's always going to be two terms, okay? You're going to have two terms. Both of them are going to be perfect squares, meaning if you were to take the square root of both of these numbers or both of these terms, you would get a perfect answer. The other main thing to notice is it says difference of squares, which means it has to be a subtraction sign for this to work. So basically what you want to do is you want to take the square root of both of these. And you're going to have two different binomials. Okay, so you're going to square the first term. So if you square x squared, you end up with just x because x times x is x squared. So the first term for both of these is going to be the square root of whatever this first term is. So the square root of x squared is just x. Then you take the square root of 36. Well, that's 6. So you're going to put 6 as the second term in your binomial. And here's the key part. It becomes the positive and the negative of whatever the last term is squared. So your answer is just x plus 6 times x minus 6. And you can check, so I'll even show you how it works. You can check it. So you can take x plus 6 times x minus 6 and make sure you end up with the same thing. Well, x times x is x squared. X times negative 6 is negative 6x. 6 times x is a positive 6x. 6 times negative 6 is a negative 36. When you combine these like terms right here, negative 6x plus a 6x, they cancel. So you're left with x squared minus 6, which is what we started with. So that's how you know you're good. So it's really nice because you don't have to do a lot of extra work here. So if we look at this next example, so this time we're taking it a little farther because now a doesn't equal 1. There's a number in front of it. But notice 16 is still a perfect square. Y squared is a perfect square. And so is 64. And we still have this subtraction sign. So if you want to use the fact that this is perfect square, you take 16y squared and you take the square root of it. Well, the square root of 16 is 4. Square root of y squared is just y. So the first term is a 4y. Then you square this 64. Well, the square root of 64 is 8. So you're going to have an 8, and you make one positive, one negative. And that's your answer. So they work out really, really nicely. This next example is a little trickier. I wanted to kind of show you a few different tricks. So here you have an x squared as the first term, which you know is a perfect square, minus 9y squared. Well, notice there's a variable in the first and the second term. Well, that's okay. You can still do this. You're just going to have a variable with both terms. So we're still going to have a binomial times a binomial. When you square x squared, you get x. When you square 9y squared, you get a 3y. Because the square root of 9 is 3. Square root of y squared is just y. And then one's positive, one's negative. So there's your answer. This example here is kind of a little trickier. So you've got n squared minus 65. So n squared is a perfect square. 65 is not. So we would actually call this prime because you cannot factor it. So if you can't factor it, you would just call it prime. So that's the first case. So that's difference of squares. Now we're going to look at the second case. So the second case is a little bit more different. So we have our normal trinomials here. So we've got x squared minus 8x plus 16. And we're just going to factor this like normal. Well, notice a is 1. So we're going to use the trick to where you just find two factors of 16 that when you add them up, give you a -8. So if we take 16, since it's a -8, our factors are going to have to be negative to get a positive 16. So you've got -1, -16, -2, -8, -4, -4. And there you have it. A -4 plus a -4 is a -8. So that means our factors are both -4. Now here's the part where this becomes a special case. Notice it is the exact same factor twice. So you have x minus 4 times x minus 4. Well, when you're multiplying something by itself, you're squaring it. So the way you actually want to write this is x minus 4 squared. This would be the correct answer. Okay. So here's another example. If you want to pause this and try it on your own, go for it. I'm going to go ahead and go through it. But like I said, if you want to pause the video now and try this example on your own, it's no problem. So what we have is a y squared plus 16y plus 64. Again, a is 1. So we just need to find two factors of 64 that give us a 16 when we add them together. Well, you have 1 and 64, 2 and 32, 4 and 16, 8 and 8. Well, 8 plus 8 is 16, so there's our factors. So you've got y plus 8 times y plus 8. It's the same factor twice, so you would rewrite it as y plus 8 squared. So those are your special cases, okay? This is what your homework is going to be over. It's that Canvas quiz, as I said, so make sure you do that and get that done. And then tomorrow is going to be kind of a overall taking factoring and doing a bunch of different factoring problems together where you factor completely. So that's it for today. Stay safe, stay healthy. See you guys.